Ghost galaxies. They exist, but you won't see them in the deep reaches of the cosmos. Far from the blazing cores of luminous galaxies, there exist systems so faint, so tenuous, they barely leave a trace. These are ghost galaxies, diffuse, vanishing, and anomalous objects that challenge our understanding of galactic formation and structure. Their light, stretched thin across enormous volumes, barely rises above the cosmic background, making them nearly invisible to most telescopes. Yet their presence is undeniable, detected through careful astronomical surveys and gravitational clues. The invisible is real, and it is stranger than we imagined. Among the most perplexing of these are DF2 and DF4, two galaxies in the NGC 1052 group that have become famous for what they seem to lack: dark matter. In a universe where nearly every galaxy appears bound together by the unseen grip of dark matter, DF2 and DF4 appear to defy the rules. Their stars move more slowly than expected, indicating that there's not enough mass to explain their structure through gravity alone, unless, somehow, they formed without dark matter at all. This isn't just a curiosity, it's a potential crack in the standard model of cosmology. If confirmed, galaxies like these could rewrite our understanding of how galaxies form, evolve, and interact with their environments. Even more bizarre are the ultra-diffuse galaxies, UDGs, sometimes as large as the Milky Way but with 1,000 times fewer stars. These ghostly giants haunt galaxy clusters and voids alike, stretched out into ethereal shapes that defy gravitational expectations. How such delicate structures survive the violent gravitational tides of the universe remains a mystery. Some researchers suggest that they might be held together by extraordinarily massive dark matter halos, far more massive than their visible matter would suggest. Others think they're remnants of galactic collisions, puffed up by tidal forces and now drifting through space like the cosmic dead. One particularly haunting example is a ghost galaxy adrift in a cosmic void, an immense region of space almost entirely devoid of other matter. With no nearby neighbors to disturb it and no dense background of stars to hide its pale glow, this lone galaxy became detectable thanks to the isolation that usually conceals such faint objects. It reveals a strange truth: sometimes, to see what is nearly invisible, you have to look into emptiness. These void dwellers are natural laboratories, allowing us to study galactic evolution in the absence of typical environmental influences. Ghost galaxies are not only hard to see, they are hard to believe. Some defy classification entirely. They rotate like disks but look like elliptical blobs. They contain ancient stars but show signs of recent formation. Their shapes, kinematics, and environments suggest a galactic evolution that follows rules we don't yet understand. They are galaxies that seem to exist in contradiction, visible but unseeable, real but nearly absent from the sky. These paradoxes fuel speculation. Are ghost galaxies mistakes of nature or artifacts of our limited understanding? Some astronomers propose that what we are observing may be transitional phases, brief, unstable moments in a galaxy's lifetime that we rarely catch. Others argue they might be the survivors of cosmic catastrophes, stripped of their gas, puffed up by gravitational harassment, left behind as spectral relics of more massive progenitors. Still others suggest observational bias, hinting that countless ghost galaxies remain undiscovered simply because our instruments were never designed to find them. Recent advances, however, are changing that. Deep sky surveys like those conducted by the Dragonfly telephoto array and instruments on the Hubble Space Telescope are finally sensitive enough to detect these fragile structures. The Dragonfly Array, in particular, was built specifically to look for low-surface brightness objects, using a novel design that minimizes light scattering and reveals faint details most telescopes wash out. Through this lens, the night sky suddenly teems with apparitions, galaxies we never knew were there, floating quietly in the cosmic dark. The existence of galaxies like DF2 and DF4 has triggered intense debate over how such systems can exist without the invisible scaffolding of dark matter. Is it possible that their dark matter was stripped away through tidal interactions with nearby galaxies? Could their formation have followed an entirely different path, one not reliant on the presence of a massive halo? Or, more radically, might these observations be pointing to flaws in our very conception of gravity and mass on cosmic scales? Ghost galaxies blur the lines between presence and absence. Their diffuse halos stretch into the void, barely distinguishable from background noise. Their stars are ancient, yet their structures appear youthful and unstable. They exist in defiance of conventional categories, sometimes orbiting within clusters, sometimes wandering alone, sometimes appearing in places where no galaxy should logically be. Every discovery deepens the enigma. Some of the most compelling enigmas come from the behavior of ghost galaxies within galactic clusters. In regions packed with gravitational interactions, ultra-diffuse galaxies often appear abundant, yet fragile, hovering at the edge of existence. How do such low-mass, low-brightness objects survive the tidal forces and collisions that rip apart more robust systems? One hypothesis suggests that these galaxies might possess extremely massive dark matter halos, granting them a kind of invisible armor. Paradoxically, their ghostly appearance may hide a core of exceptional resilience. At the same time, other ghost galaxies seem to have formed in isolation, untouched by such violence, drifting through intergalactic space like fossilized echoes. These solitary wanderers challenge any simple, universal model of galactic evolution. Their very presence hints at multiple formation channels, some violent, some passive, some still unknown. In some cases, ghost galaxies retain the memory of structure, faint spiral arms, diffuse central bulges, or elongated tidal tails, ghosts within ghosts, remnants of a past more defined and luminous. There are also systems so faint that even calling them galaxies stretches our definitions. These objects, teetering on the threshold between star clusters and full-fledged galaxies, raise difficult questions about what makes a galaxy a galaxy. Is it mass? Size? Presence of dark matter? Gravitational independence? Ghost galaxies force us to confront these definitions, exposing the artificial boundaries in our cosmic taxonomy. In the most extreme cases, we observe galaxies that are both ghostly and anomalously active, diffuse systems somehow birthing new stars in isolated clumps, without the dense molecular clouds we usually associate with star formation. How do such diffuse regions cool and collapse? What fuels these unexpected bursts of light in otherwise dark systems? The mechanisms remain obscure, but the implications are profound. Even in the most tenuous environments, the universe finds a way to ignite its fires. In some ghost galaxies, the star-forming regions flicker like dying embers, casting a faint glow into the abyss. Others harbor compact star clusters embedded in their diffuse halos, dense knots of stars that seem out of place, like pearls scattered across fog. These clusters, sometimes more gravitationally bound than the galaxy itself, raise the possibility that ghost galaxies might be stripped-down remnants, their outer layers torn away, leaving only faint memories of former grandeur. Perhaps these are the bones of once vibrant systems, left to drift through cosmic time, their structures unraveled by ancient interactions. One haunting hypothesis is that some ghost galaxies are the afterimages of failed galaxies, cosmic embryos that never fully developed. They may have formed in regions with just enough mass to begin assembling stars, but not enough to sustain growth. Without sufficient dark matter or without the gravitational heft to retain their gas, star formation sputtered out early. These are galaxies arrested in infancy, frozen in a state between existence and non-existence. Observationally, their detection remains an enormous challenge. Many ghost galaxies have surface brightness levels lower than the night sky itself. Traditional optical surveys overlook them completely, their faint halos indistinguishable from background noise. Only with advances in deep imaging techniques, noise reduction algorithms, and specialized arrays can we begin to map their presence. Even then, interpretation is complex. Are we seeing entire galaxies, or fragments? Are we mistaking shadows for structures? Ghost galaxies also highlight a philosophical tension in astronomy. They are real, measurable systems, yet they teeter on the edge of invisibility. Their existence relies on the sensitivity of our instruments, the patience of our surveys, and often, a bit of cosmic luck. Their story is not just one of matter and light, but of perception and thresholds, what we define as real in a universe where most of what exists is hidden, silent, and dark. These elusive structures serve as quiet reminders that the cosmos is not built solely from brilliance. For every radiant spiral or blinding quasar, there may be countless ghostly counterparts slipping unnoticed through the dark. They whisper of a hidden universe, one composed not only of what shines, but of what fades, disperses, and defies detection. In this silent majority, the rules may bend. Here, the relationships between light and mass, between structure and gravity, are not what they seem. Even the role of environment becomes ambiguous. In dense clusters, ghost galaxies might be survivors of violent harassment, bloated by gravitational tides. In voids, they might be pristine fossils, untouched by external influence, holding secrets of the early universe. Some may even transition between these states, galaxies that were once bright and structured, now drifting into obscurity, dissolving across epochs. There are ghost galaxies with irregular kinematics, where stars orbit in chaotic patterns or drift without a clear rotational axis. This could suggest disrupted formation histories, ongoing tidal stripping, or exotic gravitational effects. Some researchers have speculated that these strange motions might even be clues to modified theories of gravity, alternative models attempting to replace the unseen hand of dark matter. In that sense, ghost galaxies become not only astrophysical mysteries but philosophical battlegrounds for our deepest assumptions about reality. They are also time capsules. Because their stars tend to be ancient, with little fresh gas to sustain new generations, ghost galaxies offer a snapshot of the early universe frozen in place. Studying their chemical makeup can reveal when and how quickly their star formation shut down, what kind of supernovae shaped them, and whether they had neighbors or merged with others long ago. Their spectra are like the fading echoes of a cosmic song that once played loudly and now barely murmurs. And yet, for all their silence, ghost galaxies may hold some of the most important answers about the universe's past, and its fate. Their fragile light carries imprints of the first stars, the earliest mergers, and perhaps even the primordial conditions that set the stage for galactic architecture. Because they evolve so slowly, or have already ceased evolving altogether, they preserve clues long since erased in more dynamic galaxies. Some ghost galaxies orbit larger hosts like faint shadows, their structures stretched and torn by tidal forces. These satellite ghosts are laboratories for studying galactic cannibalism in action. We see them dissolving into stellar streams, becoming one with the halo of a dominant galaxy. Others, however, remain stubbornly intact, orbiting quietly with no clear signs of disruption. Their persistence raises questions. Are they protected by unusually massive dark matter halos? Are we missing some stabilizing factor in our models of interaction? Then there are those that seem to appear in defiance of all logic, galaxies that should not have survived, or should never have formed in their present state. They are the statistical outliers, the cosmic accidents, the wrong answers that refuse to be erased. Perhaps they are rare byproducts of unknown processes. Perhaps our simulations are missing key physics. Or perhaps the universe is more tolerant of exceptions than we ever realized. Their rarity, or our inability to find them, also feeds a deeper unease. What else are we missing? If entire galaxies can remain hidden until the right technology or observation strategy comes along, how many other categories of cosmic structure have yet to be revealed? Ghost galaxies serve as both subject and metaphor, proving that visibility is not the same as presence, and that absence of evidence is not evidence of absence. They also challenge the narrative of progress we often project onto the cosmos, the idea that galaxies must grow brighter, denser, more complex with time. Ghost galaxies suggest the opposite can happen, a quiet undoing, a long exhalation into nothingness. In them, we glimpse the entropy of galactic evolution, the fading of cosmic architecture into formlessness. Their structures are smeared, their boundaries soft, their identities unstable. They are what remains when energy runs low, when collisions are over, when the fires of star formation go cold. Some ghost galaxies even stretch our concept of individuality. In low-density regions, we find systems so diffuse that it's difficult to determine where one ends and the intergalactic medium begins. Their stars are not bound tightly, their halos barely distinguishable from background noise. Are these galaxies at all, or something more primitive? Could they represent a bridge between galaxies and the ambient fabric of the universe, a kind of transitional matter that speaks to the continuum of structure rather than clear divisions? As instruments improve, more such questions will rise. Next-generation surveys from observatories like the Vera C. Rubin Observatory, LSST, will peer deeper and more broadly than ever before, and are expected to unveil hundreds, possibly thousands, of ultra-diffuse and ghost-like galaxies. But finding them is only the beginning. Interpreting their nature, origin, and future will demand new frameworks, ones that can account for objects that do not fit neatly into our established categories of elliptical, spiral, or irregular. Ghost galaxies are neither vibrant nor dead. They exist in between, in a state of partial being. Perhaps this is why they resonate so deeply with us. They are mirrors of cosmic uncertainty, of the ambiguous, of the almost forgotten. They remind us that not all stories end in brilliance. Some fade, slowly, beautifully, into the dark. In that fading, ghost galaxies speak to the quiet vastness of the cosmos, its patience, its subtlety, its capacity to harbor forms of existence that go unnoticed for eons. They embody the truth that the universe is not a place of constant spectacle, but also of shadowed persistence, of structures that whisper rather than shout. In their diffuse outlines and minimal light, they tell stories as profound as the most luminous quasars or explosive supernovae. Some researchers now speculate that ghost galaxies might outnumber their brighter cousins. If even a fraction of them remain undetected due to their faintness, the census of the cosmos could be missing entire populations. These systems might account for discrepancies in mass distribution, star formation history, or even in the inferred geometry of large-scale cosmic structures. In this light, ghost galaxies are not merely peculiarities, they are essential pieces of the universal puzzle. And there's poetry in their contradiction: galaxies that exist to the fullest cosmic definition, vast, structured, gravitationally bound, but whose very existence seems to defy perception. They are both there and not there. They participate in the cosmic web, yet hover on the edge of non-being. It's a paradox that calls into question the limits of our observational reach, and the definitions we use to label reality. Ultimately, ghost galaxies are reminders of humility. For all our tools and theories, for all the light we capture and quantify, there remains an overwhelming abundance we cannot yet grasp. The universe is filled not only with the unseen, but with the barely visible, with echoes, with silences, with the pale signatures of ancient processes still reverberating in the dark. To understand ghost galaxies is not just to study faint light, it is to explore the margins of knowledge, where existence itself becomes an open question. To truly grasp the significance of ghost galaxies, we must confront not only their physical attributes but also their philosophical implications. These enigmatic systems sit at the crossroads of cosmology, astrophysics, and metaphysics, challenging both our scientific frameworks and our existential assumptions. In the vast ledger of the universe, they are entries written in faded ink, hard to read, easy to overlook, but undeniably present. Their discovery forces us to reconsider what counts as a galaxy, what defines structure, and what constitutes visibility in a cosmos where the majority of matter is inherently dark. From an astrophysical standpoint, ghost galaxies are laboratories of extremes. They allow us to test models of star formation at the lower limits of gas density and gravitational cohesion. In most galaxies, star formation is tightly linked to the presence of cold, dense molecular gas, but in ghost galaxies, stars have somehow formed, or are still forming, under diffuse and unstructured conditions. This raises the question: what sparks star formation when the usual ingredients are so diluted? Do these galaxies possess unique cooling pathways, aided perhaps by trace metals or environmental factors we have yet to quantify? In their diffuse light, ghost galaxies also carry signatures of chemical history. By analyzing the elemental composition of their stars, we can trace back their enrichment over cosmic time. Are they the products of ancient, metal-poor starbursts, or have they undergone quiet, prolonged chemical evolution? Some appear to contain only old, red stars, suggesting they formed rapidly in the early universe and then faded away. Others display signs of intermittent rejuvenation, hinting at sporadic accretion events or minor mergers that reignited brief periods of star birth. Their dynamics are no less perplexing. While many ghost galaxies show signs of dark matter deficiency, like DF2 and DF4, others seem to require massive halos to remain gravitationally coherent. This inconsistency suggests that ghost galaxies are not a monolithic class but a spectrum of outcomes arising from different cosmic conditions. Some may be tidal remnants or puffed-up dwarfs, others may be relics of failed galaxy formation, or even ancient survivors of a more chaotic cosmic epoch. There may be dozens of formation pathways leading to ghostliness, each revealing a different facet of the universe's evolution. Gravitationally, these galaxies also offer unique opportunities. In clusters, ultra-diffuse galaxies may interact subtly with the surrounding gravitational field, acting as probes of the cluster's dark matter distribution. If they are indeed dominated by dark matter, they can be used as tracers to map unseen structures. If they lack dark matter, their motion, or lack thereof, can inform modified gravity theories, like modified Newtonian dynamics, which propose alternatives to the dark matter paradigm. In this way, ghost galaxies are not just anomalies, they are data points that could redefine the fundamental laws of nature. In the context of cosmic evolution, ghost galaxies may serve as a kind of galactic fossil record. Just as paleontologists study the imprints of bones in ancient stone, astronomers study the spectral and structural imprints of stars in faint galaxies to reconstruct their life stories. Were they once vibrant spirals stripped by galactic collisions? Did they form in the turbulent filaments of the cosmic web and fade as the universe expanded and cooled? Or are they something altogether different, a hidden population that evolved under rare and isolated conditions? From a cosmological perspective, their existence also touches on the question of cosmic fairness. Are these galaxies rare exceptions, or are we simply blind to the most common forms of galactic structure? The observable universe may be lit up by bright galaxies, but its scaffolding could be filled with ghosts, countless barely luminous systems that quietly shape the large-scale distribution of matter and gravitational potential. If we only count what we can easily see, we risk misjudging the contents and architecture of the cosmos. Moreover, ghost galaxies are a meditation on thresholds, on the boundary between presence and absence. They reveal that galaxies are not binary entities that either exist or do not, but that they occupy a continuous space of visibility, bounded by technology, time, and perception. Their light may be too faint for the human eye, but their gravitational fingerprints, their stellar populations, and their lingering radiation testify to their reality. Like the whisper of a voice in a vast cave, their signal may be faint, but it echoes nonetheless. As future instruments come online, like the Roman Space Telescope, the European Extremely Large Telescope, ELT, and the Square Kilometre Array, SK, we may find that ghost galaxies are not the edge case, but the norm. The universe could be teeming with shadows we have only just begun to detect. These tools, with their unprecedented sensitivity and resolution, will peel back the layers of cosmic invisibility, revealing the low-brightness frontier in full detail. In doing so, they will not only refine our maps of the universe, but also expand our definitions of what it means to be seen, to exist, to matter. Ghost galaxies remind us that visibility is not a requirement for importance. In a cosmos filled with light and noise, it is often the quietest voices that speak the deepest truths. These diffuse, nearly forgotten systems challenge us to look harder, think deeper, and remain open to the possibility that the universe is far more mysterious, more nuanced, and more hauntingly beautiful than we have ever dared to believe. They also invite us to contemplate the ultimate fate of galaxies, and perhaps the fate of the universe itself. If galaxies can fade, if their stars can disperse, if their structures can dissolve into diffuse ghosts, then what becomes of cosmic architecture in the long run? Ghost galaxies may be a preview of that distant, entropic future where luminous galaxies dim, star formation halts, and the universe enters its quiet twilight. In their spectral outlines, we may be glimpsing not only relics of the past, but echoes of the future. There's a profound stillness in ghost galaxies. Unlike the dynamic chaos of colliding galaxies, or the furious starbirth in starburst cores, ghost galaxies exist in a state of suspended motion. Their stars orbit slowly, widely spaced, often without clear rotation. Some lack a central bulge, or any central structure at all. They are clouds of memory, gravitationally bound, but barely. Some even seem to defy stability altogether, as though the faint cohesion they exhibit is itself a mystery. In recent years, observations of large-scale cosmic voids, the immense regions of near-empty space between filaments of galaxies, have uncovered ghost galaxies existing in near-total isolation. These are perhaps the most haunting of all, galaxies that formed, evolved, and survived with virtually no external influence. With no galactic neighbors to strip their gas, or cluster tides to disrupt them, these systems evolved like islands in a cosmic sea. They are untouched, unspoiled, but also underfed, slowly fading as their limited gas supply dwindles and star formation grinds to a halt. One such example, sometimes referred to as the void ghost, revealed itself only through deep imaging and careful subtraction of sky background light. Its surface brightness was so low that it had evaded detection for decades. Yet its structure was unmistakable, an extended halo of stars, no central nucleus, no recent star formation, no interaction signatures. It was simply there, an echo of formation, floating in the dark. These void ghosts may be especially valuable to cosmology. Free from the confounding variables of crowded clusters or merger histories, they offer relatively clean windows into early formation conditions. In their chemical simplicity and structural quiet, they preserve the fingerprints of primordial processes that shaped the first galaxies. They are, in a sense, cosmic control samples, pristine baselines against which more complex systems can be compared. And yet, for all their scientific value, it is their strangeness that captivates us. Ghost galaxies are not simply odd or extreme cases, they are boundary breakers. They exist in tension with our models, our expectations, even our instruments. They remind us that science is not the cataloging of certainty, but the exploration of anomaly. Every ghost galaxy is a riddle wrapped in soft light, a challenge to our understanding, and an invitation to widen our perspective. Perhaps one day, with more complete surveys and more sensitive instruments, we will come to see the sky not as sparsely populated with rare ghosts, but densely threaded with them, revealing a hidden architecture of cosmic memory. Perhaps the ghosts will prove to be the silent majority, and the luminous galaxies we know so well will be the exceptions. In this way, ghost galaxies transcend data. They become a metaphor for the universe itself, immense, mostly invisible, delicately structured, filled with mysteries we've only begun to perceive. They dwell on the margins of being, visible yet fading, coherent yet diffuse, ancient yet persistent. And in the silence of their dim light, they speak of a cosmos far deeper, and far more shadowed, than we ever imagined. Ghost galaxies also compel us to redefine our relationship with the cosmos, not only as observers, but as participants in a larger, evolving system of perception. They expose the limitations of our tools, yes, but also the boundaries of our imagination. In a universe often simplified into luminous points of data, stars, galaxies, quasars, these ghostly structures demand nuance. They teach us to listen to the quiet, to detect patterns in the barely there, and to value what cannot be easily quantified. In them, science and philosophy merge into a singular inquiry: what does it mean to exist when no one is watching? The study of ghost galaxies also intersects with the profound mysteries of dark matter, one of the most elusive components of the universe. In galaxies like DF2 and DF4, the apparent absence of dark matter sparks uncomfortable questions. If these galaxies truly lack this invisible glue that binds most galactic systems together, how did they form? Are they anomalies, stripped of their dark matter by tidal interactions with larger galaxies? Or were they born without it, as relics of a unique formation pathway that sidesteps standard cosmological models? Alternatively, could our understanding of gravity itself be flawed? Modified theories of gravity, such as Mond or emergent gravity, gain traction in the face of systems that refuse to conform. Ghost galaxies thus become philosophical battlegrounds, not only between theories of matter, but between paradigms of reality. Every such galaxy detected without its dark halo raises the stakes in the quiet war between observational astrophysics and the theoretical underpinnings of modern cosmology. There is also a haunting beauty in the structure of these galaxies, particularly ultra-diffuse galaxies, UDGs, which stretch across sizes comparable to the Milky Way but with a fraction of the stars. Their morphology can be unsettling. Smooth gradients of faint light, barely perceptible central cores, scattered globular clusters that appear disconnected from the whole. Some UDGs even contain an unusual abundance of globular clusters, as though their past was far more dynamic than their present suggests. These ancient star clusters orbit within ghost galaxies like the remnants of forgotten narratives, tracing out invisible histories written in gravitational arcs. One theory posits that some UDGs are failed giants, galaxies that formed like regular spirals, but whose gas was stripped early, preventing full star formation. Others suggest they may have once been compact galaxies, puffed up by interactions, expanding like smoke rings through the intergalactic medium. Their puffed-up size, in contrast with their dimness, makes them seem like apparitions, too large to be overlooked, too faint to be noticed. And then there are galaxies that blur the line between being and not being, stealth galaxies. These are systems so faint and so low in stellar mass that they have likely eluded even our deepest surveys. Theoretical simulations suggest their existence in large numbers, orbiting galaxies like the Milky Way, their gravitational signatures embedded in the subtle motions of stars and gas. They are the ghosts among ghosts, potentially plentiful, but detectable only indirectly, like whispers in a crowded room. As we improve our ability to detect low surface brightness features, we may discover that many structures we thought were isolated or simple are, in fact, surrounded by ghostly companions, tidal debris, stellar streams, and diffuse satellites. Ghost galaxies may be everywhere, painting the cosmos with a kind of cosmic patina, soft, widespread, ancient light woven into the scaffolding of the universe. Even the cosmic web, the immense, filamentary structure of matter spanning billions of light-years, may be populated with ghost galaxies along its strands. These galaxies could serve as low-luminosity markers of the web's fine-grained architecture, tracing its form like beads on a spider's thread. Their light may be weak, but their spatial distribution encodes the geometry of the universe itself. And in all this, ghost galaxies echo a deeper truth: the cosmos is not defined by what we see, but by what we fail to see. The luminous matter, the stars and galaxies we celebrate, is merely the illuminated tip of a vast, shadowed iceberg. Below that threshold lie ghost galaxies, dark matter, intergalactic gas, sterile neutrinos, and perhaps other, as yet unimagined forms of matter and energy. In their ghostly light, we find the limits of perception, and beyond those limits, the endless invitation to continue searching. For ghost galaxies do not merely ask us to look harder, they ask us to see differently. To develop instruments not only of metal and glass, but of thought and patience. They ask us to let go of easy categories and embrace ambiguity, not as failure, but as the birthplace of discovery. In this way, ghost galaxies may be among the most meaningful discoveries of modern astrophysics, not because they dazzle, but because they endure. Not because they shine, but because they persist. They are the silent monuments of a universe that is not only vibrant, but slow, and strange, and haunted by its own ancient memory. A universe that continues to unfold, one faint galaxy at a time. And so, in the quiet persistence of ghost galaxies, we encounter a radical shift in cosmic storytelling. Traditionally, the narrative of the universe is driven by brightness, by cataclysms and creation, supernovae and quasars, by the blaze of starbirth and the thunder of black hole mergers. But ghost galaxies offer a counterpoint, a narrative of stillness, of entropy, of fading and forgetting. They are not the fireworks of the cosmos, but its ashes, and within those ashes, profound truths are written. These truths are not only astrophysical, they are temporal. Ghost galaxies stretch our understanding of time on cosmic scales. In their faded light lies the memory of a universe much younger, more chaotic, more fertile. Some ghost galaxies are remnants of ancient formation epochs, survivors of violent rearrangements in the early cosmos. Others are slowly transitioning now, fading from more active forms into passive relics, dissolving into diffuse halos of stars and gas. A few may be future ghosts in the making, galaxies that still form stars, but only barely, their reservoirs running dry. This evolutionary spectrum suggests that ghostliness is not a static state, but a phase, a stage through which many galaxies may pass as they age, interact, or are stripped by larger structures. Ghost galaxies are not merely failed systems or anomalies. They are transitions. They are becoming. And in that sense, they offer us a way to understand not only what galaxies are, but what they become, and by extension, what the universe itself is becoming over time. In that becoming lies another frontier, the intersection of matter and identity. When does a galaxy stop being a galaxy? Is it when star formation ceases? When dark matter is stripped away? When its stars are too faint to detect? Ghost galaxies live along these boundaries, challenging our definitions with every observation. They are thresholds made visible, between matter and emptiness, structure and dispersion, presence and absence. They also remind us of the power of the collective. A single ghost galaxy may seem fragile, insignificant. But together, they may contribute a substantial fraction of baryonic matter to the universe. They may shape the dynamical environment of galactic halos, contribute to reionization histories, and affect the formation of globular clusters and satellite systems. They may play key roles in the architecture of galaxy clusters, acting as tracers of gravitational potential wells that we have previously underestimated. Moreover, they may help resolve the missing satellite problem, the discrepancy between the number of dwarf galaxies predicted by simulations and those actually observed. If many of these satellites are ghost galaxies, too diffuse to be seen by conventional means, then the problem dissolves not through new physics, but through new vision. And with that new vision comes a more complete map of the universe, not one drawn only by brightness, but one sketched in shadow. Even the aesthetics of ghost galaxies carry a strange beauty. Their forms are often delicate, like spilled ink on velvet. Some resemble clouds, others appear as faint smudges, and a few are so faint they disappear entirely unless imaged with the utmost care. And yet, within their modest luminosity lies complexity, stellar populations of different ages, metallicity gradients, substructures shaped by long-ago interactions. They are not blank slates, but quiet texts, layered with the scars and scripts of ancient astrophysical drama. To study them is to adopt a slower gaze. To seek not the spectacle, but the whisper. It is an act of patience and humility, a willingness to sit with ambiguity and infer presence from the barest trace. In that way, ghost galaxies are not only cosmic structures. They are teachers. They instruct us to listen to the faint, to be attentive to the marginal, to believe in what is barely there. And perhaps, in this lesson, we find an echo of our own place in the cosmos. Humanity, too, is a faint structure in a vast and ancient universe. Like ghost galaxies, we are built from memory and starlight, fragile in form but persistent in presence. To see the ghost galaxy is to see ourselves, not as dominant observers standing outside the universe, but as quiet participants, flickering for a time, suspended in the long unfolding of cosmic history. In the end, ghost galaxies are not merely astronomical curiosities. They are philosophical provocations. They ask what it means to be seen, to persist, to matter. They blur the boundary between the visible and the invisible, the defined and the diffuse. They dwell in the cosmos like forgotten songs, still playing softly beneath the static. And if we listen closely, beyond the noise of light, beyond the glare of the obvious, we might just hear them singing still. This song, the song of ghost galaxies, is a hymn not to brilliance, but to endurance. To presence in silence. To the vast and slow-burning processes that sculpt the universe not with explosions, but with erasure. These galaxies have been shaped not only by what happened within them, but by what was taken from them, gas lost to tidal forces, stars scattered by gravitational interactions, dark matter stripped by neighboring giants. They are survivors of subtraction. Galaxies that have endured by fading, not resisting. In this way, ghost galaxies challenge our cultural assumptions about power, permanence, and visibility. We are conditioned to equate luminosity with significance, mass with influence, clarity with truth. But the cosmos resists these metaphors. The most powerful structures may be those we cannot see. The most enduring galaxies may be the ones that no longer shine. And the most meaningful cosmic stories may be those written not in the bright strokes of starbursts, but in the smudged ink of ancient, diffuse light. They also raise compelling questions about cosmic entropy and the ultimate destiny of structure. If galaxies can fade into near invisibility, and if this fate awaits even the brightest giants, then ghost galaxies may represent a preview of the long future of cosmic evolution, a future where structure remains, but only barely, where stars no longer form, but still drift, where the grand architecture of the early universe becomes a mist of old orbits and fading starlight. In this far future cosmology, ghost galaxies may not be rare, they may be all that's left. And yet, even in this vision of fading, there is wonder. A ghost galaxy is not nothing, it is almost nothing. It is the persistence of form just above the threshold of perception. It is a gravitational fingerprint left behind by epochs of motion and memory. It is a structure that, in spite of overwhelming odds, remains. And that act of remaining, of not vanishing entirely, is itself an act of cosmic defiance. There is something deeply poetic in this. That in the vast universe, there exist entities that do not shine, do not cry out, do not demand attention, and yet they endure. They are not the loudest, the biggest, or the most active. But they are there, woven into the fabric of the cosmos, shaping its structure, bearing witness to its evolution, and waiting for us to notice. As astronomers refine their techniques, stacking images, mapping gravitational interactions, improving contrast filters, and scanning deeper regions of the sky, we are beginning to pull back the veil. What once appeared as void is now revealed to be full of quiet complexity. What was dismissed as absence becomes rich with presence. In time, our cosmic maps will be redrawn, not as charts of glowing islands in a sea of darkness, but as vast, interconnected networks of both light and shadow. And as that new cartography emerges, ghost galaxies will take their place not at the margins, but at the center of our understanding. They will remind us that the universe is not composed solely of things we can see, or even measure, but also of things we must infer, imagine, and believe in before we can fully comprehend them. In their presence, we are invited into a new kind of astronomy, one not built entirely on photons, but on patience. Not only on discovery, but on contemplation. It is a science that acknowledges mystery as a permanent feature of the cosmos, and sees beauty not only in revelation, but in restraint. Ghost galaxies are the cosmos in its quietest voice. They are the low-frequency harmonics of a universe that sings across the spectrum of time and matter. And when we attune ourselves to them, we not only expand our understanding of galaxies, we expand our understanding of being. Ghost galaxies, in their subtlety and stillness, represent the quiet frontier of cosmology, the edge not just of what we can observe, but of what we can imagine. They are monuments to the invisible, systems that formed under the same universal laws as the great spirals and luminous ellipticals, yet evolved into something else entirely. Something softer, more elusive. Something that does not seek attention, but that rewards the attentive. In studying these vanishing giants, these spectral outliers, we are forced to confront the humility of knowledge. We begin to understand that the visible universe, the glowing web of stars and fire, is only the thinnest surface of a much deeper and darker cosmos. A cosmos where things may exist without ever revealing themselves. A cosmos where silence is not emptiness, but information waiting to be decoded. And this humility transforms us. As we trace the faint trails of ghost galaxies, we begin to see our own world differently, not as central, but peripheral. Not as the exception, but as one among countless manifestations of a universe that often prefers the unnoticed to the obvious. We begin to ask not just what galaxies are, but what they mean, as symbols of persistence, as thresholds of visibility, as metaphors for the unknown. Ghost galaxies are not only remnants of a different cosmic era, they are guides toward a different way of thinking. They call us to see the universe not as a museum of luminous relics, but as a living archive, its shelves filled with light and shadow, action and aftermath, presence and trace. They tell us that not all structure is born from accumulation, some is born from erosion. That not all meaning is found in brightness, some is written in the fading glow of memory. In the end, to study ghost galaxies is to become fluent in subtlety. To listen beyond the static. To observe beyond the light. To imagine structures that survive not by burning brighter, but by holding together through the gentle gravity of time. They are evidence that in a universe governed by chaos and collapse, there are still systems that whisper their stories through the veil of darkness. And perhaps this is their greatest lesson, that even in the cold, quiet outskirts of being, even in the aftermath of light, something endures. Something persists. Not in grandeur, but in grace. Not in visibility, but in presence. Ghost galaxies are the echoes of creation and the prologue to oblivion, and in that paradox, they may be the most honest expression of what the universe truly is: vast, intricate, mysterious, and infinitely more beautiful than what shines.